let us look at the scalar product of two vectors. Now, I have a diagram here. We'll soon be using this diagram, alright? Now here, the scalar product. The scalar product of two vectors also called the dot product tells how much the vectors point in the same direction. All right? So here, if you have two vectors, this vector, let's call it A, and you have this vector, let's call it B. If they point in the same direction, then they completely, well, of course, how much do they point in the same direction? Perfectly. 100%. Alright? Now the angle between them, call it theta, is equal to 0 degrees. Now, here, the formula for the dot product. If you have A, let's put a line here for A and B to show that they are vectors. If you have vector A, now remember from before, you could call this lowercase a in bold or with the line, or you could say you label the vectors so that one side is A and the other side is B. So we could have said vector AB or vector CD or something like that. But let's keep it this way for now. Vector A dot vector B is equal to, now what that is, the formula for it, of course, the magnitude of A multiplied by, we put a dot there, by the magnitude of B times cosine of the angle between them, theta. So you might have a case where you have A looks like this and B looks like this. Theta would be this angle, alright? In this case, the angle is 0. So, when theta is 0, right, then A dot B, if you have the two vectors A and B, A dot B is equal to the magnitude of A times the magnitude of B times cosine of 0. But what is cosine of 0? The cosine of 0 is 1. So, it is the magnitude of A multiplied by the magnitude of B, or that magnitude of B, times 1, which is just 1. 100% in the same direction, right? Now, you can say that the dot product shows how much the vectors are helping each other. Alright? How much vector B is helping A. So A dot B is showing how much, what you're saying is, how much is vector B helping vector A. So they're pointing in the same direction. So if A was 10 Newton, a force of 10 Newton, and B is a force of 10 Newton, the total will be 10 plus 10, which is 20. Now, suppose you have a case where A is somewhat like this and B is at an angle here. It's somewhat like this, right? Now, this angle here, let's call it 30 degrees. Let's work in degree for now, 30 degrees. Then vector A, that vector B would be equal to A, whatever it is, dot B times cosine 30. Now what is the cosine of 30 degrees? All right, make sure it's in degree. 30 cos 0.866. 0.866. So this is 0.866 times A dot B. So B is not helping A at 100%, only partially. Alright? Suppose A and B were like this. You had A here and B is pointing down like this. Then how much is B helping A? Well, let's see. The dot product of A and B is equal to, oh, I didn't put the magnitude, remember, the magnitude signs would be here. Alright, good. Magnitude of A times the magnitude of B times cosine what? This angle is 90. Cos 90. Now what is the cosine of 90? Well, if we find, let's clear the calculator, 90 cos is 0. Right? So this is 0. So B is not helping A at all. Right? It's not helping A. Now, suppose you have another situation where A and B are like this. Then this is A and you have B. Now the thing is, this angle, let us say it is at 90, 100, 120 degrees. Then A dot B would be equal to the magnitude of A times the magnitude of B times the cosine of 120 degrees. Now, we want to find out how much B is helping A. My calculator disappeared. Let me get it back. Alright. So, 120 cos. Negative half. Negative 0.5. So, B is acting against A. Now, let's look at this. The portion of B in the direction of A would be this. Here, the portion of B in the direction of A would be 0. But here now, the portion of B that's in the direction of A is this is opposite to A. So it's pulling back A instead of helping it. Right? So here, B is helping A somewhat up here, pointing in the same direction. B is helping A fully, 100%, cos 0 is 1. Here, B is helping A only partially, at 30 degrees, here 90 degrees. B is not helping A at all. It's like A is acting on its own, not giving any help at all. But this makes it worse now. B is opposing A, it's fighting against A, it's pulling against A, opposing A, right? So it's not that it's helping partially or none at all, it's actually opposing A. Part of B is opposing A. Alright, so see that product there. Now, back up here. Let us see what the situation will be when we have a vector in 3 dimensions. Alright? I'm thinking, we could just do that in our next video. So I'll see you then.